Welcome back. We are going to finish this problem. So we were going to start by finding the inverse of a 3 by 3 matrix given by A. We began the problem by rewriting the matrix A, drawing our vertical line, and then writing the 3 by 3 identity. And our goal is to, through row reductions, turn this side of the vertical bar into the 3 by 3 identity matrix. All the while, this side will be keeping track of all the changes that we've made, and whenever this has become the 3 by 3 identity, then this, if properly done, will be A inverse. Let's get started here. Take a moment to look at the different rows, and remember our first step is to get a 1 in this entry. Let's think about how we might do that. While there's many ways to get a 1 as this entry, we might first just start by multiplying the entire row 1 by 1/2. Okay. We're going to multiply row 1 by 1/2, and that will be our new row 1. So let's write out this matrix. Okay. What we're doing here is only affecting row 1, so we can quickly write out row 2 and row 3 unchanged, and then every entry in row 1 is going to be multiplied by 1/2, would give us 1, 1.5, 0.5, 0.5, 0, and 0. Our next goal is to get this entry to be a 0, and then when we're done with that, to get this entry to be a 0. Okay. Let's first work on getting this entry here to be a 0. We could do that by multiplying the top row by -3, and then in a subsequent step, adding that new row 1 plus row 2, and that will go to a 0. Let's work on that. And then we know that next we could take this row 1, multiply it by -2, subsequently add it to this row 3, and that will turn that into a 0. Work through that, pause the video on your own time, and then we'll check our solution together. -3 times row 1 will give us -3, -4.5, -1.5, -1.5, 0, and 0. Our next step, since we would like this entry to become a 0, is we can find that by adding row 1 plus row 2, okay, and that will become our new row 2. Okay. Take a moment to do this addition and then check your work, so I'd recommend you pause the video, work through the addition, and then check your answer. I'll try to remember to write the new steps in red, so I just wrote this one here so we can see it more clearly, but adding these two entries together we get 0, these two together we get -1.5, these two together we get -0.5, and so on. And then we only changed row 1 in order to later affect row 2, so let's go back to our original row 1, okay, which can be found here. Okay. So we rewrote row 1. Okay. Now our goal is to make this into a 0. We'll do it in a similar way. This row 1 times -2, rewrite that, add to row 3 now, and that will become our new row 3. Okay. -2 times row 1 becomes our new row 1, which we'll get to be these entries. Okay. So we get -2, -3, -1, -1, 0, and 0. And row 2 and row 3 remain the same at this point. Our next step will be to take row 1 plus row 3, and that will become our new row 3. Okay. So let's add these rows together. -2 plus 2 gives us 0. -3 plus 4 gives us 1. -1 plus 1, 0. -1, 0 plus 0, 0. 0 plus 1 is 1. Okay. And we will rewrite row 2. Okay. And then we will go back to the row 1 that we had before, right here. So we keep track. Our goal is to make this look like the 3 by 3 identity. So we really would like whatever is in this entry to be a 1. Now we could multiply the current row 2 by a scalar to make this a 1, but since this is already a 1 here in the second column of the third row, why not just switch row 2 and row 3, and then we'll get the 1 there like we were hoping for. So we'll do that in our next step. So here we're going to switch row 2 and row 3. So we've switched row 2 and row 3 as we see here. We know our next goal is to get this entry to be a 0. We could do that by multiplying row 2 by 1.5 and then seeing that when we add row 2 and row 3 after doing that, this entry would cancel to a 0. Let's do that in our next steps. Multiplying row 2 by 1.5, we get this. Next, we will take row 2 plus row 3, and that'll become our new row 3. Pause the video and work through that next step. We would get this after adding row 2 and row 3, and then we would go back to our previous version of row 2. I actually just noticed an error. I apologize for that. If we see, whenever we add these two entries together to have gotten this entry, we actually wouldn't get 0. We would get -3. So hopefully you didn't make that mistake, but if you were just following me, make sure to correct that on your paper. This entry, when adding these two together, should give us -3. So with that important correction, let's now focus on our next goal, which is to get this entry to be a 1. Okay. Notice we could get this entry to be a 1 if we multiply this entire row by -2. So our next is going to be -2 times row 3 will be our new row 3. Okay. Take a minute to write the resulting matrix. Multiplying row 3 times -2 would give us this row. Okay. And now, since this entry is already a 0, our next goal will be to make this entry a 0. Okay. We can do that by taking 1/2 times row 3, and then once finding that new row, we would then add that to row 1, and we'll make this into a 0. So notice what we were doing is trying to get this entry to be a 0. So we multiplied row 3 by -1/2. But as I was doing that, I kind of noticed, do you see we just got back to where we were one stage earlier? So perhaps a more efficient way to solve this problem in retrospect would be to, at this point, before we multiplied by a -1/2, take advantage of the fact that these two entries are 0.5 and -0.5. So I could have, maybe as a faster solution, added row 1 plus row 3 to be my new row 3 at that point. Okay. If I had done that, that would have put a 0 in this place, kept track of the changes in the other locations as well. And then after doing that, then multiply -2 times row 3 to be the new row 3. And we get to the same stage, but it might seem a little less redundant because here we change the scalar to then change it back. So that's just a quick note. I'm going to continue with what we were doing here, but I did want to point that out as a faster solution. But sometimes you only see these things in retrospect. So we're going to add row 1 plus row 3. 0 plus 1, 1. And then for our row 3, we're going to revert back to our previous row 3. 0, 0, 1. Okay. We are almost finished. We only have one final thing. We would like this entry to be a 0. Okay. We could see that we might do that by taking row 2 times -1.5 and then adding row 1 and row 2 together. So let's do these final steps. We found our new row 2. Our final step will be to add row 1 plus row 2. We would add these entries, so we would get 1, 0, 0, -1, 1, 0. And then we will revert back to our previous version of row 2 before we made this scalar change. We get this as our reverting back to our previous version of row 2, and we see that the left side of this vertical bar is the 3 by 3 identity. So then, since we know that then this is our A inverse. So we take our final step, write out our answer. A inverse then is the matrix -1, 1, 0, -1, 0, 1, 6, -2, -3. Okay. And as before, we always have a way that we can check our work when it comes to finding an inverse matrix, because we know that we could take the original matrix A times our found A inverse. And in this case, since A started as a 3 by 3 identity, A inverse should give us, A times A inverse should give us the 3 by 3 identity. Similarly, we could find A inverse times A, and we would still get the 3 by 3 identity. So I recommend you take a moment and multiply A times the A inverse that we found, and just verify that we do indeed get the 3 by 3 identity matrix.